Did you come to say hi to these humans?
Trying to flip her paper on the floor. This one I just gave you evil eye. That one I'm ignoring. She's just rude.
Who's rude? Oh!
Abby, and then Ann over there. She's hiding behind the mask. Just say no.
Well, Shane comes in every morning to make coffee during zero period. And he only turns on one light.
He's saving energy.
I guess so. He's
going green.
Doesn't this look so fun to do? Abdel said it looks hard. Woo. Hello. So I want to go over the alternating series paper. Wow, what happened to this room? Are we just missing one person? But it really looks like a lot. We're just missing Denny. Yeah. Somebody else in this room. No. Julia, does anybody sit in front of you? Think of it. No one sits there. He's tall. Yeah, he just looks like he takes up a lot of area, I guess. So we want to go over the alternating series paper. Yes. How do you feel about that? Just with our, you feel good about that? Like, is this a thumbs up? Oh, I see some sideways lines. Okay, good. Then I want to go through like that conditionally convergent thing, just because I think it'd be cool for you to see. Like, I think it's just kind of neat. Then if we have time, we'll start the next test, which is the ratio test. But you probably aren't going to get problems. You won't get the sheet for the ratio test today. Probably get that on Monday. But I might create a delta math. I got to look through delta math to see how their series of constants problems work. If they have any, I don't think they do. But if they do, I might give you like 5 or 10 of those just to play with over the weekend. We might have another quiz on Monday. Because I've got to give you another quiz before we have tests. Right? Before we actually have a test, you probably need to have another quiz. And the problem is Tuesday is what? Air day. Well, here's the thing. You guys are going to need to come in either Tuesday or Wednesday for class. Like, I mean, now, I guess I could stream whatever we do, like, but like, we cannot just throw out these air days. Like, oh, I mean, it's just not happening. Sorry, like, I don't know what to do. Like, I talked to my last period, and they were like, I said, well, I can make a video and post the video for you just to do on the air days. And they were like, well, I'd rather come in. That's what the other class said. So what's that? No. Many of you have to come in anyway because you're going to sports practices in the afternoon. I'm not going to say come in at 9. So here's what I think I'll do is on Tuesday and Wednesday, we'll do the same thing. We'll have the same class twice. So you can come in Tuesday, like during essentially regular class time, or you can come in Wednesday at like, I don't know, 2:30. We'll finalize that more on Monday of next week, but that's kind of what I'm thinking. And I mean, I guess you don't have to come. I mean, if you don't come, you don't come. But like, I'm having class, and if you want to learn the stuff, like, yeah.
Okay. So you write the exam, right? What if you just didn't put stuff on the exam that we didn't have time to learn? Can that happen, or would
Yeah, I'm not doing that.
Because Wright State won't let you, or because you don't want to?
Because I mean, I can't with integrity say that you've earned credit for calc2 when we basically just throw away the last unit because Kettering City Schools decided to let you guys out of school on May 7th when it was not, I mean, you basically have just given up 2 weeks of the class. Like, and you're going to get credit for calc2. Like, I can't not teach you that content or expose you to that content. And then when you go, many of you guys are going to go on next year and take differential equations. Like, you can't go into a differential equations class and then all of a sudden you're going to be sitting there and like, oh yeah, we're going to be solving differential equations by looking at power series expansions. And you're going to be like, I don't know what, like, I don't even know what a power series is. Like, that's problematic. I mean, I can't do that to you. Now, for you, it might not matter because maybe you're not going to take differential equations. And you're like, okay, I'm good to go. I mean, which I can understand the position that you're coming from, but, and normally speaking too, I also have to like, normal years, Wright State asks to see the exam that I make up. Now, they may or may not this year just because it's a crazy year, but I just can't do that. Like, that's not fair to those kids that are going to need that content. Yeah.
Are you gonna live stream class the days that we have air testing or not the air testing going on?
I can, yeah. Hopefully there'll be some people here that it just makes it like better for you. I don't know. I mean, honestly, like, I recognize this is not ideal. It sucks. Like, the whole year has sucked, and in all honesty, I could not be more impressed with how the majority of you have responded in this. Like, you definitely have learned way more content from first semester than I would have guessed that you would have in a million years. Like, that's evident on how you're doing now and how you were doing at the end of last semester, when we first came back. Like, that blew my mind because I think given the conditions and like, that was awful. I mean, just awful. So like, I think you guys have accomplished a ton, but I also, I can't just throw stuff out. Like, we've already thrown some stuff out. But, yeah. It sounds like I know I sound like a jerk. What's up with it? What do you got to know?
Oh, so what time are we looking at?
Well, I was thinking if we do one day, so we're still throwing out one day next week because we're just going to do the same thing on Tuesday and Wednesday, right? So, if we do, I was thinking of doing one like during regular class time and one in the afternoon in case, just to be more accommodating. You know what I mean? So one of the days that like Wednesday, maybe we'll do it in the afternoon, and then Tuesday we would just do it during regular class time. I mean, I know a lot of folks are coming back for practices, right? So like, you got to be at school at 3:30, so just come in an hour early at 2:30. And those career tech kids, they all have to come in. Like, that's the crazy thing. Like, during Wednesdays, when you guys are all, when half of you guys aren't coming to school, like, those career tech kids have to come in. Some of them, I don't know about all of them.
Engineering.
Yeah, I don't know, some of them do, I mean, that's, because that was a huge controversy back in the day. Yeah,
During the air test on Tuesday, are we gonna be like, I feel like I remember we're not allowed in the building, or we gonna be allowed to come in, like, are the officers gonna let us in?
oh, wait, you know what, you just, I think I might have to flip-flop that, because on Tuesday, I'll be giving an air test during class. You're right, I just realized that. Yeah, so, and the reason I thought that is because there so many years I didn't have an advisory, and so I wasn't doing air testing, so I kind of, forgot about that, but I have an advisory, so I'll be giving air testing. So maybe we'll have to do both of them in the afternoon. Yeah, that's a very good point.
Like, we can still come in on Tuesday?
Yeah, but it would be after school, or in the afternoon, not after school, but in the afternoon. Like,
Oh,
air tests will be over at like noon. So maybe like on Tuesday at 2:30 and then Wednesday at 2:30. We'll just do the same class both days. Yeah, thanks for coming back. I forgot about that. Yeah, I'm gonna be busy during that time. Yeah, so, and we can stream it too, but again, it's just not the same. Yeah.
So I get out at 12:30, so I usually go to work after that.
You get out of school at 12:30?
I do get out.
Well, you're always in my room, like hanging out. Like, is that your day is over at 12:30?
Yeah, that's how I'm in your room. Class.
So you're one of your jobs, like.
Well, like I don't get my schedule till like this Saturday, but like sometimes they'll have me come in early because I do get out.
Yeah, I mean, I guess in that, I mean, like if you can't come, you can't come. I mean, I can't force you to do anything. Like, I mean, you can just watch the video or whatever. Like, that's fine. I mean, it doesn't matter. I just can't. The thing is what I can't do is just give you 2 days off next week and say, oh yeah, we're just not going to learn anything. We're like, yeah, it's just a vacation day. In addition to the 14 extra days that you get at the end of the year, just, oh yeah, we'll just throw out more days. Like, you can't do that. I mean, it's like, you guys are learning calc2, right? Second semester calculus, you're meeting 4 times a week for 40 minutes. That's what you're doing. You're meeting 4 times a week for 40 minutes, and we're expected to do calc2 in 4 times a week in 40 minutes, starting at the end of January, and then finishing what's your last day? May 3rd, May 5th? I don't know what. Like, that's virtually impossible. I mean, if you were to take that course at Wright State, you would have started at the beginning of January. It would have meant 5 times a week for 50 minutes. Yeah. And you would have gone from the beginning of January until the end of April, first week of May. Like, that's 20% of the content, 20% of the contact time you guys are not getting because weekend Wednesday. And 40 minutes a week. And that 40 minutes a week, if you think about it, like, that's 10 minutes off each period, right? That's a lot of minutes over a week. So, and again, I'm amazed that we've gotten done what we've gotten done. I mean, honestly. But we are throwing, I mean, there's a whole unit that we're not learning. That, those kids that take calc2, that's going to be a big deal, but we'll figure that out later. So please don't think I'm sure. I mean, I'm doing this because I care. But yeah, so Wednesday and Tuesday will have to be in the afternoon. Julia, I'm so glad you said that. I would have made all these plans and then like Monday night I would have been like, oh crap. Yeah, okay, so like, is 2:30, is that a decent time? I mean, except for Annie and Becca.
We do it a little early.
Yeah, same.
Because
We have practice.
practice is at like 15, but
Oh, 3:50. I was thinking it was 3:30. Yeah, we can go too. That's fine. I mean, I'm here all day. I don't care.
How about one?
No. No, he's got to sleep till 12:45. Yeah, I'll look at, over the night, I'll look and we'll tell you on Monday, like exactly. But yeah, it'll be somewhere around 2. I mean, that's fine. I mean, we want to have enough time to have actual 40 minutes of class. And then again, if you got to work or whatever, just watch the video. I mean, and realistically, any of you could do that, but I think there are people that would rather come in because it's just better. Yeah.
So are both classes gonna come in at the same time?
Yeah, but not everybody's going to come, so I think it would be okay. I mean, there's 2 in here that already aren't.
I'm gonna come.
You just said you had to work.
I didn't say that. I
Oh.
just said I get out at 12:30.
I mean, I might go to our 12 crowd, but I just might.
I called dibs on the seat.
So we'll make it work. How many of you think that you would not come? You don't want to get shamed. You don't want to raise your hand. I don't want to get yelled at. I mean, it doesn't matter. It is what it is. So. Yeah, we'll figure it out. The other class is pretty small. Although it probably wouldn't be socially distanced.
Are we right
Just
now?
make them stand.
Are we right now? I don't know. I'm not even sure what the rules are anymore. It's hard to keep track. So. All right. Well, you want to talk about this? So you're going to give me just answers real fast?
Yeah.
And you're not necessarily the work, but I'll just give you the answers and we can talk about them if you have questions. Okay, number 1, that should have been, that's an easy one, hopefully. That's conditional. Number 2 is diverges. Okay, number 2 diverges because the terms aren't going to 0. Was that not a surprise to you when I said that?
Yeah.
What are the terms doing there?
Approaching 1/2.
Yeah, they're like positive 1/2 or negative 1/2, right? Okay, number 3 is conditional. 4 is conditional. 5 is conditional. 6 is diverging. 6 and 7 are basically the same series. It's also diverging. So now do you see other ways of generating a positive negative? If you actually listed out the terms of 6 and 7, it would be 1 or negative 1. See that? Cosine of n pi, cosine of 1 pi, cosine of 2 pi, cosine of 3 pi. That's going to be 1, 0, negative 1, 0, 1, 0, negative 1. Just alternating those. Number 8 is conditional. Number 9, what do we think there?
Absolutely.
It's absolute, right? Woohoo! Number 10 is diverging. Number 10 diverges for a very similar reason that number 2 did. The terms are not going to 0. Okay. Number 11 is conditional. Number 12 is absolute. And 13 is absolute. Okay, so questions on any of those? Question.
Can you do 2? Is it just because it doesn't go to 0?
Yeah, I mean, we can write it out and kind of just so you can visualize what's going on there. But in number 2, we have these, woohoo, negative 1 to the n palm into n plus minus 1. So like if you just look at this limit, right? It kind of ignoring the -1 to the n. And even if you want to put the -1 to the n in there, it doesn't matter. Like this is not going to approach 0. Like the absolute value of the terms, like the terms are going to either be, they're approaching 1/2 and -1/2. So that diverges, okay? Now, if say that n wasn't there and it was that, then it would converge, and then we would have to go through and find out whether it's conditional or absolute, right? And then in this case, it would be conditional.
For a lot of them, do we just ignore the like -1 to the n and look at what everything else does?
Well, essentially, you're going to do that at some point in your evaluation of that series. You're going to ignore the -1 to the n and look at everything else at some point. In this one, we saw that right away and saw that the terms weren't going to 0. Now, if we ignored the -1 to the n and we saw that the terms were going to 0, then we need to make a determination of, okay, is this absolute or conditional? And, how do you go about doing that? As I, when on that one right there, when I erase that n in the numerator, right? If I erase that n in the numerator, I'm just looking at this series, right? So if it was just -1 to the n over 2n minus 1, and pretend that was the problem, which I think there's one on there like that. Number 8's very much like this, right? Is this conditional or absolute? The terms are going to 0, correct? Because like Megan said, if I ignore that -1 to the n, the terms are going to 0. So yeah, this definitely converges. Now is it conditional or absolute? So now when I do ignore the -1 to the n and I look at this series right here, which is the same thing as this series right here. Now does that converge? And we can just look at that if we want and know, like using our kind of reducing rule. What does this series sort of reduce to? Like a 1 over n, right? And what does that do? 1 over n diverges, right? So then because 1 over n diverges, that guy diverges, so this guy's conditional. Okay? Does that make sense, Megan? It definitely makes a big difference if you think 1 over n converges. That'll definitely throw a wrench in your getting correct answers. Other ones? Like, why is number 9 absolute? Why is number 9 absolute?
The P series n over 3/2, which makes it convert.
Right. Because when you absolute value the terms, right, you get 1 over n to the 3/2, which is a P series that converges. Right? What about number 11 and number 4? Okay, number 11 and number 4, those are very similar. Okay? Number 11 and number 4 are very similar. So the terms are going to 0. The absolute value of the terms are going to 0. So that converges as an alternator. But what happens if I take the absolute value and determine? Does this converge? Which is basically saying, does that converge? Right? So now we have to answer that question. That's not necessarily an easy one to just look at. Okay? It's hard. I mean, it just one over natural log of n. You don't have any sort of intuition about that. But if you do a comparison with 1 over n, Can you tell me how 1 over a natural log of n compares to 1 over n? Okay. Well, who's bigger, natural log of n or n? Well, if you think about this, here's the natural log function, right? Here's y equals x, or y equals n. Okay? Natural log is always below this one. So this is smaller than this. The denominator has a smaller denominator than this one, right? So what does that tell you about this fraction? He's bigger. So he's bigger than 1 over n, which means he diverges. So this guy then is conditional. Okay. And then you, for the same reason, if you go back and think about number 2 or the one before that, where it's this guy, like that, you can make the same argument that we just made, right? So that's why he's conditional also. Other questions? How many of you got all those right? Which one did you miss? Or ones? I mean, which ones did you miss? I saw you making a lot of check marks. Oh, well, that was the one that everybody like made a goofy noise when I said the answer. Number 2. Did you just not see that n up in the numerator? That you forgot about that?
I feel like I don't know when to like look at it just like that or to like start solving. Finding this out.
So if I hand you a series, okay, if I hand you a series, the first thing that you should do is determine if the terms are going to 0. Because if the terms are not going to go to 0, the discussion, you don't even do anything. You diverge. You don't have to do any work at all. So that's your entry point, right? And so so you're looking at number 2 and you're like, I didn't know what to do. Should I start working on this? Or like, first thing you should look at is the terms are going to 0. Because if they're not, it's over. You're done. And so that's the case with number 10 and number 2. Right? Yeah.
Is that because of the nth term?
Yeah. Exactly. I mean, you think about the alternating series, like, yeah, an alternating series converges when the terms are going to 0, but it has to be alternating. If the terms aren't going to 0, it diverges. Like, that's basically the nth term test. Okay? If the terms are not going to 0, it diverges. Game, set, match. Yeah.
Will we ever have like a sine or cosine one that alternates and doesn't diverge? The one that converges.
Well, you could have this. You see what that is?
Yeah.
Like this right here is basically generating a 1, -1, 1, -1, 1, -1, and then over n squared. I mean, that series, what I just wrote down, and this series right here, essentially the same thing. Does that make sense?
Yeah.
Because cosine of n pi and -1 to the n, it's basically just 2 different ways of generating that -1, +1, -1, +1, -1. Yeah.
So that would be absolute.
That's a good question. Would that be absolute or conditional? Why?
PC
Because yeah, you ignore 1 over the negative 1, you just got 1 over n squared. That's straight p. Right? Woo, yes, great. Okay, what about the answers to the bottom? Like, so I'll tell you, here's how I would have done the bottom. Now, how I would have done them may not be how you did them, and you still did them correctly. Okay, number 1 is converging, that's p series. P is 3 halves. 2 diverges. Why? In term tests. The terms are not going to 0. 3 to the n is going to beat the out of n squared. Right? Number 3. It's geometric. And it's a converging geometric, right? Even, Megan, like going back to your question, or was it Becca's question? I can't remember. Like even the geometric series test. When the geometric series test, when r is greater than 1, we say it diverges, right? That's because when r is greater than 1, the terms aren't going to 0. It's also the nth term test. Right? Number 3 or 4? That's conditional, yeah. I mean, that problem is on there like 4 times. I mean, number 4, number 1 at the top, number 3 at the top, number 8 at the top. Those are all essentially the same problem. You guys see that? Yeah.
So what test is being used for?
For number 4?
Yeah.
Well, it's an alternating, right? Because the terms are going to 0 and it's alternating sign. But when I just look at 1 over n plus 4, that's like, yeah, I mean, because remember I told you when you're doing conditional, you can do the hand wave, like you can kind of just say, well, this reduces to 1 over n. But if we were doing it formally, we would say that it was probably a limit comparison test or direct comparison.
So you're gonna put like your test on it?
Hand wave test, yeah. Okay, number 5. What about that one? You think it diverges?
Yeah.
So if I look at number 5, I almost feel like we've had this series before, but so the Ellie rule is, okay, well, I guess we first got to do this. Does that equal 0? It does, okay? So now we got to do something else because we don't know what's going on, right? I would try, because I know that 1 over n is, like, n is growing faster than natural log of n, okay? So I think I'm going to just try to do this with a limit comparison with 1 over n. And the reason why is I feel like this one diverges. I just have a feel. So I'm going to test my feeling, right? So we'll do a limit comparison test with 1 over n. So I'm going to do 1 over n over natural log of n over n. So what happens here? So if I have 1 over n, that's going to be n over natural log of n. What happens there? What do you get? 0. What does that tell me? Tells me nothing with the limit comparison test. Right? So I can't use 1 over n. I was just about to say, as I was writing this down, because as soon as I wrote this, I knew that was going to happen. I knew 0 was going to happen. I was like, okay, I got to think ahead. Like, what are we going to do instead? And I was like, oh wait, this is a pretty easy integral test one. I think this one started at 2, didn't it? So if I do this integral, this is a u sub. Yeah? So this ends up being u du, u squared over 2, and evaluate that from 2 to infinity. That's going to diverge all over the place. Right? Oh, sorry. Well, it won't be. You can't evaluate it yet. Natural log of x squared over 2. So that diverges? Was that the one that was on your quiz? Is that where we saw that one? Or the one in the bottom right corner on your quiz? It had a natural log in it. Didn't it? Am I crazy? Oh, so I'm not crazy. No. That was 1 over n natural log n. All right. What else? Oh, 2 at the bottom. I was like, Megan, you just asked me about 2 5 minutes ago. 2 at the bottom. Sorry. I was like, are you losing your head? So this one here, Megan, if I just do this for number 2 at the bottom, right? We got to take that limit. Now, we could go through the whole L'Hopital's rule thing, but this is big time top heavy, right? Because 3 to the n is growing a lot faster than n squared. So because that's top heavy, that limits infinity, so the terms aren't going to 0. Yeah.
So going back, you know how we did the comparison test in Excel? Can you choose another one that, like, let's say you chose a different divergent series? Could it have worked or will it always?
I'm not going to say that it would always fail, because there's probably, I mean, it's certainly possible that there's something out there that I could have chosen that would have worked. But I can also say, just from looking at this structure, like on how this ended up, that any P series that I would have used would have not worked. Like, do you see that? Like, if I would have used 1 over n squared, or 1 over n to the 1/2, like any P series, you were going to end up getting either infinity or 0 there. So that wouldn't work. Now, is there some other thing I maybe could have used? Possibly. Maybe I could have used the one that was on the quiz. Like, and done a limit comparison with that one. Because the natural log would have gone away. Possibly. But saying always makes me nervous. But I think any P series would not work. What other questions? Yes, no? Can we do this in 2 minutes? I don't know. It's not going to be easy to do. I think I'll have to do it on Monday. Show you how conditionally convergent series can add up to 2 different things. I've actually got this applet. It's the last thing that I found on Twitter. But there's this little applet this website that has an applet on it that you can go to that has the alternating harmonic series. And you can make the sum be whatever number you want, so you can drag the y-axis up, and it'll like rearrange the terms and show you how it'll make that add up to that number. It's crazy. Like, I'm fascinated by that. The fact that you can take all these numbers and make it add up to 1, or you can make it add up to 600. That seems kind of weird, don't you think?
They're adding and subtracting, though, right?
Yeah. And the gist of it is basically this. Say you wanted to add up to 50. You just add up all the positive terms until you get to 50. And then you add up all the negative terms until you go under 50. Then you add up all the positive terms until you get above 50. Then after all, and you just keep doing that until it smashes down. Yeah.
When you said it was commutative properties, I don't think it would be uninsured.
Well, this is true, isn't it? 1 plus negative 1/2 is the same thing as negative 1/2 plus 1. Isn't it?
Yeah. I don't know. I just remember from elementary school, where you can't use commutative properties with negative.
Well, 5 minus 7 does not equal 7 minus 5. That's true. But 5 plus negative 7 does equal negative 7 plus 5. Because really, there's no such thing as subtraction. Right?
I mean, if you think about it, just adding negative.
Yeah. And adding negative numbers is kind of good. But when you change to subtraction, it's not.
I do okay.
I got my, last night, I was like, I don't know.
On this?
I got like, oh.
Oh.
And that doesn't get
Like, this is why we have to meet outside of school. Like, because we spent a whole day going over the answers to those problems. Like that's important. We got to do that. You can't just say, "Oh, well, you caught it. You're screwed." What you got it?
Why? Is that what you're talking about now?
Yeah, like because next week I told them on the air day. I was like, I'm gonna give you one day. Like, but I'm gonna have class on Tuesday or Wednesday in the afternoon.
You're mad about that?
You're gonna have to come in if you want. So you can also stay home and watch it, but like a lot of kids would rather come in.
Yeah.
Like, but we just can't. You can't just give you 2 days off. Like, what the heck? I mean.
Yeah.
And that's the perfect reason why is because of what Ellie said.
Maybe if you didn't get shot, I wouldn't have that problem.
What?
Maybe if you didn't get shot, I wouldn't have that problem.
You need to get some kills.
Can't.
Right here.
I'm pretty sure the floor's gonna get like shut down.
Yeah. Or down.
I think
two
Austin's,
kids.
you are?
Jack and Tank got shot. So it's,
Yeah, we were supposed to play whoever wins.
you're gonna play NC.
Yeah, I think it's gonna shut down, because I think Austin's gonna stop things throughout the whole day. So. And he sent that email yesterday. So. Yeah. What your parents did?
Yeah.
Well, my team didn't do anything bad, so. I don't even know, what was the thing about like the median?
About the what?
There's something, like some like median in the road got like destroyed or something in the email. I don't know. I knew about the like, someone was shooting a BB gun,
Yeah.
but there's something else in the email that I don't know what happened.
Oh, never mind, dude. Not where the money's going. I'm just Brewer. Oh. That's her face.
Oh, gosh. Where is everybody?
Yeah, that's soccer game.
You don't have a soccer game?
No, I didn't play club.
You're done with the club. How's that feel?
Weird, but.
Is it liberating?
I mean, I liked my club team because it was just like fun.
Is it
Like it
bittersweet?
was not serious. Like Mia's club team was super serious. Mine was like. It was more fun.
Who does Mia play for?
I don't know. She like, I think it's like 10 bits or something. She plays for different clubs. And she like plays with like class.
What position does Mia play?
I don't know what she plays for her club team because it's honestly different. But for high school, she played like some defense and more midfield this year. But she is like switched around, so I don't know. But Nicole is at the Alley Healthcare.
Yeah. So, I almost got tarred and feathered last period. Where's Billy?
I got a lot of work.
What?
I think I've got a lot more high school today. I think all my classes was like.
Well, it's Friday. I mean, we just take the day off. Because on Monday or Tuesday and Wednesday of next week, like I think I'm gonna have a class in the afternoon, like for one of those days. Does that make sense? So you can come in either day. Now I can't force you to come in, like, you know. I guess I can't do that, but so I mean we'll still stream it or whatever, but we just, I mean, we can't just take 2 days off, like, we're so close to. If we take 2 days off next week, 2 days off the week after, basically we have 4 days left. Or 6 days left, or something like that.
What time do the air test end on Tuesday?
Like at noonish, so we'll do it like at, 2 o'clock. So around 2 o'clock, we'll have people come in. And it'll be the same class both days, so not everybody's gonna come. So we won't be overcrowded. And then also on Monday, we're gonna have another quiz. Because I got to give you another quiz before we get the test. Okay. The last period wanted to crucify me.
It'll just be like an hour.
Yeah, like just at the end of the day, right? Before track practice starts or before whatever starts. Although you do a spring sport. Oh, you're working.
Yes.
So are you going to be working at noon for 2 o'clock those
I don't
days?
know about Wednesday.
Yeah, Annie said she worked.
Yes, we work every.
She was one of the ones that wanted to crucify me.
We work every.
Do you get free food there?
50% off.
We got some good pasta. I feel like they also have good pizzas.
Yeah, I've had a lot of.
I haven't been there in 10 years. So do you want me to give you some answers on your paper from last time? Let's talk about that. Bum, 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 bum. Is Billy absent from school today?
I haven't seen him all day. I don't have any classes with him.
Oh, so you normally don't see him? Okay, so we ready? What do we have for number 1? Please tell me you're conditional. That was the one that we. That's the alternating harmonic theory. Okay, number 2 diverges. Okay. Number 2 diverges because it's the nth term test. Okay, the terms are not going to 0. All right. That n in the numerator causes problems. All right. What about number 3? Number 3 is conditional. Number 4 is conditional. Number 5 is conditional.
Can you go over number 4?
Yeah, I'll come back to it. So 5 is conditional also. 6 and 7 are basically the same series. In fact, 6 and 7, that's how you can, another way that you can generate a plus, minus, plus, or like a positive 1, negative 1, positive 1, negative 1. Because if you think about 6, you're basically, that's essentially taking the sign of odd multiples of pi over 2. That's what that's saying there. Odd multiples of pi over 2, so take the sign of those numbers. And you're either going to get 1 or negative 1. And the cosine of n pi, that's like saying, take the cosine of all multiples of pi. Well, you're either going to get 1 or negative 1. All right. So 6 and 7 both diverge because the terms aren't going to 0.
Would 7 5 times cosine of n, or?
I was intending that to be cosine of n pi.
Yeah, either way, it's supposed to be the same.
Yeah.
Like, I think it would be the same either way.
Yeah, it would diverge either way. But I was intending that to be cosine of n pi. Number 8 is conditional. Number 9. What's number 9? Absolute. Number 10 is diverging. Terms aren't going to 0. Okay? Number 11 is very much like number 4. It's conditional. Okay? And we'll look at that one too. 12 is absolute, and 13 is absolute. Okay? 13 is very similar to the one we did in class as the example. But let's look at number 11. Okay, so that's the series in number 11. Right? Now, are the terms going to 0? Are the terms going to 0 in number 11? Yeah, they are. Okay? Not very fast, but they are going. All right? So that's at least a converging alternating series. We just are going to determine if it's conditional or absolute. All right? So now we're going to look at the absolute value of the terms. Okay? So we're looking at that, yeah? Which is essentially the same thing as this. Now we've got to make this determination what's going on with this. 1 over natural log of n. What does that do? Does anybody know? Well, because it's just 1 over natural log of n and nothing else, there's no other n's anywhere else, I think this is probably a good way to try to do a comparison test. So right here, I'm going to do a quick comparison with 1 over n. Okay? So I'm going to say, how do these two babies compare? Okay? Well, maybe you don't know. Maybe you don't know how the natural log of n and n compare, but it's actually pretty easy to visualize. If you visualize that's natural log of x, that's y equals x. Y equals x is always above natural log of x. So n is always going to be bigger than natural log of n. So which fraction is bigger? If this guy's got a bigger denominator than this guy, he's the bigger fraction. So 1 over natural log of n is bigger than 1 over n, which means what? This guy diverges, so this guy is conditional. Okay? And you can make the exact same argument with number 4. Okay, just compare with 1 over n plus 1, which you know diverges. All right? Other question on it? Yeah.
Remember number 2 on the second part of it?
At the top or the bottom? Oh, I haven't given you those answers yet. Any ones that more at the top? Any other questions at the top? Look at what?
Is number 4 pretty much the same thing?
Yeah, 4 and number 11 are the same thing. I mean, you can make the argument that they're the same series. If you look very carefully, they actually are the same series. Because the one starts at n equals 2, And the other one starts at n equals 1, but it's natural log of n plus 1. So the first term is going to have the natural log of 2. I mean, they're the same series.
Number 4 would be 1. Negative.
The terms are opposite the negatives? Oh, well, that doesn't.
That would mean if you added it together, you get 0.
What?
If you added the two series together, you get.
Oh, well, yeah, that's a whole other discussion. But, any more at the top? You feeling it? Why is number 12 absolute? When you look at the absolute value of the terms of number 12, what are you going to end up with? 1 over e to the n squared. Right? I mean, you can compare that with almost anything. It's going to converge. Okay, number 1 at the bottom, that's a converger. P series, P equals 3/2. This is how I would do it. Now, you might be able to do it another way. Number 2 at the bottom diverges by the nth term test. Now, Alex, you asked me about that one? Or Samuel asked me about that one?
I asked you, but I couldn't figure out how to. I knew it diverged because 3 to the power of n is way faster than n squared, but I didn't know what test to use.
Well, it's the nth term test. Because this limit, the terms are actually getting huge. The terms aren't even approaching something. They're not, I mean, in order for you to converge, the terms have to approach 0. Like, they're not even approaching anything. They're just getting bigger. Okay? The reason why is this is big time top heavy compared to that. Now, if you want to see actually the proof of that using L'Hopital's rule, that's infinity over infinity, right? So we take the derivative of the top. So the derivative of the top is 3 to the n times natural log of 3. The derivative of the bottom is 2n. Still approaching infinity. So we do L'Hopital's rule again, or sorry, infinity over infinity. So we do L'Hopital's rule again. Derivative of the top is 3 to the n times natural log of 3 times natural log of 3. And the derivative of the bottom is 2. Now, as n goes to infinity, we don't have indeterminate form anymore. We have infinity. Right?
Wouldn't you have to do the derivative of natural log of 3 also?
That's 0. So it's constant.
Oh, yeah.
All right. Number 3 at the bottom. What's that one do? Why? It's geometric. What about number 4? That's conditional. Guys, look at number 4 at the bottom. Okay? Number 4 at the bottom, number 1 at the top, number 2 at the top. No, sorry, not number 2. Number 3 at the top. And number 8 at the top. So 1, 3, and 8 at the top. And number 4 at the bottom are all essentially the same series. You see that? Well, in those 4, or the ones at the bottom, I didn't stay, whether it's conditional or absolute, so you could have, I mean, if you were just following the directions, you would have just been converging. But since we're talking about it, we might as well say it. All right, number 5. This one was probably the toughest one for the folks last period. Are the terms going to 0 there? If I did the nth term test, am I going to get 0? Are the terms going to 0? Okay, we should know that because we just talked about the fact that n was growing faster than natural log of n, so the terms are going to 0. Okay? So that doesn't really help. So what I did last period is I looked at this and I said, you know what, I just feel like this one diverges. Okay? I just feel like it diverges. So I'm going to try to do a limit comparison test with one that diverges. So I chose 1 over n. So if I do a limit comparison test with 1 over n, okay, I'm going to compute this limit. So now I've got 0 over 0, so I do wait a minute. Well, I end up with natural log of n. I don't even need 0. I'm not even going to use L'Hopital's rule here because when I do this, I end up, the n's cancel, and I just get natural log of n, which is infinity, which doesn't help me, right? So the limit comparison test fails. Right? So I've got to do something else. Integral test. This thing is like screaming for the integral test. Okay? If I do the integral test, I'm going to do natural log of x over x from 2 to infinity. So u is natural log of x. Du is 1 over x. So that's u du, u squared over 2, natural log of x squared over 2, evaluated from 2 to infinity. Guess what? That's going to diverge all over the place. Right? Yeah.
So since that natural log of n is greater than 1, like very quickly, couldn't you just also do a direct comparison test to 1 over n?
Yes. Yeah, you could actually say that's bigger than 1 over n. Yeah. So the limit comparison test did not work though, right? Now, someone asked a question last period, which is a kind of an interesting question. They said, well, the limit comparison test didn't work here. Is it not going to work for anything? And I was like, well, I don't know that I want to go out and say anything. But I feel pretty confident that it's not going to work for any p-series. If you look at how that's structured there, right? But there are lots of ways, lots of different, approaches to these babies. So how do you feel? Jimmy, how do you feel?
Pretty good.
Pretty good? Aaron, how do you feel?
Pretty good.
All right. Alex?
Okay.
I was appreciate the fact that you just said something other than pretty good.
I was stuck in bed with a migraine yesterday, and there was no video on the YouTube, so this is all based on notes. I just looked up someone this morning.
Wait! There was a video there.
I didn't see one.
You mean, were you watching it live?
No, I wasn't.
So if you're not watching it live, like you got to go to the videos that are like in like past live streams. Like it's just the next, like there's, you see the tab, there's a tab, you click on live streams and then they're all there.
There's a separate tab for it?
Yeah, it's yeah. If you pull it up, I can show you.
Well, I mean, it worked out.
Oh, it's impressive. You have a migraine? That stinks. All right. Well, we have more time because the other class was trying to lynch me. So let me show you this. You don't need to write this down. Unless you're just interested in it and fascinated by it. And maybe you will be when it's all said and done. But so what do we say about a conditionally convergent series? you remember what we said? So you're telling me what the meaning of conditionally convergent. But a conditionally convergent series, you can actually rearrange the order in which you add up the terms and make it add up to different things. Okay? So I'm going to do an example of this for you right now. All right, so you all know this series, right? It's the alternating harmonic series. So if I write out the terms of it, it's 1 minus a half plus a third minus a fourth plus a fifth minus a sixth plus a seventh minus an eighth and so forth. Okay? Are you cool on that? All right. Well, I'm going to tell you right now, you're just going to have to believe me. 2 weeks from now, you'll understand why this is. But I'm going to tell you right now that we can show that this series actually equals the natural log of 2. Like all infinite number of terms added up. It equals the natural log of 2. Now you have to just trust me on that. Okay? Do you trust me? Gavin, do you trust me? So if we hold to that and we believe that, all right? Let's take this right here and multiply both sides by 1/2. So what am I going to get when I multiply this by 1/2? 1/2 minus 1/4 plus 1/6, right? Minus 1/8 plus 1/10 minus 1/6. No. Thank you. Plus 1/14. And that's going to equal then what? 1/2 times natural log of 2? Yeah. Now I'm just going to do this. I mean, this seems kind of stupid, but that's still equal to 1/2 natural log of 2, yes? Right. Okay with that? But I just put zeros there, like as placeholders. Now I want you to add these two things together. One at a time. Ready? Ready? 1 plus 0. Negative 1/2 plus 1/2. 0. Okay, I'm not going to write that. 1/3 plus 0. Minus 1/4 minus 1/4. Minus 2/4, aka minus 1/2. Okay, what are we at? 1/5 plus 0. Negative 1/6 plus 1/6. 0. So I'm not going to write that down. 1/7 plus 0. 1/7. Negative 1/8 plus 1/8. So I said not what was written. Negative 1/8 minus 1/8. Add those two together. That's negative 2/8 or negative 1/4. Okay. What's the next one here? I got more here, so I might as well do more here. Next one here is 1/9. So 1/9 plus 0. 1/9. Next one here would be negative 1/10, right? Minus, plus, minus. Yep. So negative 1/10 plus 1/10. 0. What's next here? Plus 1/11. 1/11 plus 0. 1/11. What does this equal when I add natural log of 2 plus 1/2 natural log of 2? That's equal to 3/2 natural log of 2. Yes? But look. 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5. Guess what the next term over here is going to be? Minus 1/6 plus 1/7. Guess what the next term out here is going to be? You see what's going on? Like this series right here is the same as this one right here, but the numbers are in a different order. But this apparently you agreed with me that that was natural log of 2, but we also algebraically showed that that's 3/2 natural log of 2. Well, sort of. What we can show is that this series right here, any conditionally convergent geometric series, or any conditionally convergent alternating series, you can arrange the terms to make it add up to whatever number you want. There is an arrangement of these terms right here. There's an arrangement of those terms that will add up to 7. There's an arrangement of those terms that will add up to 107. There's an arrangement of those terms that will add up to negative 7. Now, I don't necessarily know what the arrangement is, but I know it's there. Okay? Now, let me explain to you how this works. And now I'm going to show you a visual aid. I'm going to write these terms again. Okay? How many negative numbers do you see there? Or how many negative numbers are in that series? There's an infinite number of negative numbers, correct? How many positive numbers do you see? An infinite number of positive numbers. Let's say that you want to arrange those terms so that it adds up to 5. The way you do it, I'm going to explain this to you first, and I'm going to show you a visual. The way you do it is you take all the positive numbers and keep adding those positives up until you go over 5. Then you take all the negatives and you keep adding negative until you go under 5. Then you add all the positives. Keep adding positives until you go over 5. Then add all the negatives until you go under 5. And you just do that forever, and you're eventually going to smash down on 5. Wow. And that's what was happening here. We were adding positives until we got above 3/2 natural log of 2. Then we took away. Then we added. Then we took away. Then we added. Then we took away. That's how it works. A visual of this. I saw this on Twitter back in the fall. Like early in the school year. I want to say it was like August 19th. I saw this on Twitter from this math professor that I read a book of his, who's a professor at, I think it's Cornell. Oh, you guys can't see it. When I saw this back in August, I actually saved it and bookmarked it for this very day. Like, I've never seen this before, and I was like, this is crazy. I always knew about this, that a conditionally converging series can rearrange the terms to make it add up to anything you want, but I've never actually seen a visual of it and why it works. So here it is. This is wackadoo. Aaron, will you flip those lights off? Okay, so I'll share this link with everybody at some point. You guys, last period didn't get to see this, so I guess I can still put it on the Google, let you guys see it, play with it. Okay, so here's all these terms, like 1/2. Like all of these are the terms down here of the alternating harmonic series. Okay, they're in a random order right now. And what you can do is on the y-axis here, see how it says S1, S2, S3, S4, S5? That's the sum of the first one term, two terms. Those are the partial sums of that series. What you can do is you can just move this line, this horizontal line, up and down, and you can see what's going on. And you can see here, like we add up until we go over that line, then we add negatives until we go under that line. Then you add up till you go over that line, then you add negatives till you go under. And you keep doing that, and what's going to happen as you keep going further and further out? What's going to happen between these little gaps here? They're going to collapse down on 5. Or 0.57, right? Here's the various partial sums that you want to find. And here, if you really want to go crazy, you can move this. Like, you see what happened there? I mean, now I'm looking at, you can't even read the numbers down here anymore, but there's millions of them, right? See how it's collapsing in on 5 or 0.5? And if I want a different number, I just go, oh, I changed that number. That's crazy. So yeah, you can make those terms add up to whatever you want. That's pretty crazy. Because it sort of defies the idea of commutativity. A plus B equals B plus A. Now, last period, Abdel, we had to reconcile something with Abdel because he was seeing this as subtracting 1 minus 1/2. He's like, but I thought in elementary school they told us subtraction is not commutative. It's not. Subtraction is not commutative. 1 minus 1/2 is not the same thing as 1/2 minus 1, right? But 1 plus negative 1/2 is the same thing as negative 1/2 plus 1. Right? Those two are the same. But you can't just flip the order when you're subtracting. And that's because there's really no such thing as subtraction. You invented an operation. When we say subtraction, we're really inventing an operation. I mean, everything is just addition. Even multiplication is just addition. Isn't it? Isn't multiplication just addition? What's 3 times 5? 3 plus 3 plus 3 plus 3 plus 3 plus 3. What's division? Division is actually just repeated subtraction or repeated adding opposites. Like what's 10 divided by 3? It's really how many times can you take 3 out of 10? That's what division is. Right? But if you think about what is like that multiplication is just repeated addition. 3 times 5 is 3 plus 3 plus 3 plus 3. It's a sum. That's also how integration is. It's a sum. We're way off topic here. So there's a box, right? The area of that box is 3 times 5. It's repeated addition, right? 3 groups of 5. 5 plus 5. 3 groups of 5 would be 5 plus 5 plus 5, right? That's also repeated addition. It's also like multiplication. This is really like 5 times something, or sorry, this should be 3. This is really like 3 times something, right? It's not 3 times 5 though. What's happening to the something? It's changing. I mean, integration you could actually think of as it's multiplying, but when one of your things that you're multiplying by is changing. Still repeated addition though, right? We'll probably have a little quiz on Monday. I'm going to see if there's some Delta Math series of constants practice. And if there is, I'll create like a little 5 or 10 question Delta Math practice for you to do over the weekend. This is prepare for your quiz on Monday. Monday, we'll talk about the ratio test.
How many tests are there?
Ratios are our last one. There's also another one called the root test.
What test?
Root.
Root.
Yeah, like nth root. So I'll see you later, friends. I'm gonna put this on the Google so you guys can play with it. Somebody will. Hey, see ya.
I'll see you in the business later.
Yeah, produce. James, how's it going? I'm good. You heard Joe got rejected. Did you hear that? No. Yeah, it does for her. Yeah, I was kind of, you know.
Hey, Rachel. I've decided I'm not gonna finish Crooked Kingdom until I finish Shadow and Bone. Because
Really?
there's a lot of.
It's like the naval academy.
Oh, I bet there are. I bet there are. There's are. Like, I know what happens to multiple characters.
Interesting.
Oh, yeah.
That's something else.
Yeah.
multiple characters.
That's, I
Oh
think
my
that's a healthy thing to be concerned about.
Yes. Yeah.
Yeah.
I'm worried for them. I feel bad.
I know, I'm really worried after something I learned. I'm scared.
I read about it like if you already know what's gonna happen. They have to
I don't know when it's coming and I don't want it to.
Or like when a side character just all of a sudden is getting a lot of attention.
I know, you're like, oh.
No.
Yep. As soon as like they bring up the side character and you like, you know.
You know.
You're like, this is the end.
Enjoy your lunch.
You too.
Hi, Kitty.
Hi. Hi, Rachel. Charlie's not gonna be with us today. I don't know. He did not specify. Oh, that's good. How was your day? It's been alright. I'm weirdly like not as tired as I've been the past couple of days, which is just strange. I was exhausted. Enjoy the yawn. That's just made me yawn. Sorry. Yeah. And my mom got her second dose yesterday, and she's not feeling it today. No. I told her to call in sick, and she was like, I'm not. My mom she calls in sick to work. Is if like one of us is sick, and like she stays home.
Yeah, I don't like to